This lesson will teach you how to correctly use the randomized block design using and the engineering applications of it. I want to quickly start with why you would want to spend your time using the randomized block design. It reduces biased or variabilities within experiments. In engineering, the lower the variability, the better. Variability is how far data points differ from the mean, so with higher variability, it's riskier for an engineer to use that data. Some blocks are broken into categories with similar characteristics. The reason behind separating them into blocks is to reduce variability and therefore have the final statistics have less variability within each separated block. Sometimes, without breaking up the sample or population, your final statistic will end up with an inaccurate estimate. Looking at the graphic, this sample was broken into 4 blocks, then tested. This was done to decrease variability. How should you separate each block? Well, each block should be as uniform as possible, meaning keeping differences within each block minimal and the differences between each block larger. How should you use randomized block design? As a civil engineer, this statistical application can be used to our benefit. Firstly, take the population or sample that you'll be working with and separate it into parts that would cause variability within the final statistic if it's not split up. After separating, figure out which will affect the final variability the most. In my case, the location will have the most effect on different aspects of the cylinder break of the concrete because of different temperature, humidity, daylight, and even regulations. Therefore, the location will be the blocks I break the population into, leaving me with locations 1, 2, 3, and 4. Once you have broken the population into blocks, you test each block as you regularly would. For this, you would test if the concrete has a low or high break. The result of blocking in this case will give us a more accurate data because one location's attributes cannot skew the data. In the case of the example experiment I presented, with a break too high or too low, a life could be at risk if the concrete does not hold up as years go by. But the variability of the entire sample tested together would not be an accurate representation of the break if it is a good one, meaning that it would be able to withstand the conditions of location that it would be in.